right?
You drop down to the bottom where it says world temperatures, and let's say you go over to HAD CRUT 3, let's say.
Okay.
And if you just click on it where it says calculate trend right at the bottom right now,
yes,
it will show you from about 1880 up to looks like 2006 is where our database ends right now. And
wow.
Just wait a second, and a graph should come up.
Right, I see
that.
it.
Yeah, it's popped up there for me. Well, this doesn't show you quite up to the present, but you can see a peak there in about 1998, I believe it is, and then it drops down, and then it comes up again. But if you could see out to 2009, you would see that it is decreased very slowly across that point. In other words, there's probably been no warming for about 12 years, and it has a slight tendency to be cooling at the present time.
That's remarkable.
Uh-huh.
What is NOAA?
National Oceanic and Atmospheric Administration.
What do they do?
Well, they do a lot of things.
Did I ask a bad question?
Well, it's like
just
a
came to mind.
Question that's hard to give a.
Well, I mean, who do people think they are? Let's first of all find out who. When someone thinks of NOAA, what do they think what are they thinking about that they are?
Well, they study things related to the ocean and atmosphere. National Oceanic and Atmospheric Administration. They have databases of all sorts containing the things relative to the ocean and the atmosphere, and a lot of scientists working for them, and a lot of administrators, and I don't know what else to tell you.
In your work, do you ever deal with them related to CO2, or do you ever have reason to talk with them, or do scientists cross-pollinate information with them related to CO2?
Oh, I'm sure some do. We don't have anything to do with them. We probably review papers now and then that are written by some NOAA scientists, but we don't have anything to do with them directly.
Okay. So it's like a whole other focus.
Well, a lot of their focus is on the things that we're focusing on, too. But like I say, we would probably be reviewing some of the papers of some of the scientists that work for that organization.
Got it. So what else do we need to know about carbon that you haven't said?
Well, there's probably tons and tons and tons of things because, if you go to our subject index, you get another alphabet, and then you get all of these different topics. I mean, we probably have several hundred topics.
Oh, my God, you have a lot. I'm there right now. I'm at the subject index.
Topics that we file, all of these.
All related to carbon.
Yeah, articles that we write about. Yeah, I suppose you can go to carbon. You can find a lot of things under that. I'm just going to go there myself.
This is a really packed site. How long did you spend on this site? This is pretty big.
I think that we started my son started about 12 years ago, and then I came in the latter part of 2001, and we put out a new issue of this website every single week. And if you go to like our home page, you see this home page will change every week. Now my computer must be stuck. There I go. We just happen to have an extra thing at the top of this page called Copenhagen Climate Concerns. I think we got about 52 different short videos underneath that different scientists have contributed talking about the subject. Oh, and then we tell people to donate to our center. We need money. Then we have an editorial every week about something, and I see we have an extra editorial this week too. And we have this medieval warm period project where we each week publish the results of another paleoclimate study that identifies the medieval warm period, and many of them tell its warmth compared to the current time. Then we have a subject index summary. We have all these topics, these hundreds of topics, so each week we'll try to summarize the things underneath one of those topics, and that's what appears there. And we have this plant growth data section where each week we upload the results of 4 different peer-reviewed studies that have actually experimented with CO2 enrichment of plants, and we find out, how much they enhance the growth and so forth. we come down to journal reviews, where we have 5 entries each week, we usually have 2 that deal with either biology or climate, and then 3 that deal with the other one. So each week we have something of a biological nature and something of a climatic nature. And each week this changes, and next week we'll have 5 different journal reviews, and these 5 here, they'll be filed under one of the topics in our subject index.
What about the coral reefs? Can I ask you about that? What is does CO2 have anything to do with coral reefs, or the fact that the coral reefs are dying? What is going on?
Well, a lot of coral reefs have had problems for many years because of all of the things that mankind does right in their presence, right close by them, People visit there, they go down and they break off a piece to take home for their saltwater aquarium. You have other boating and so forth that goes on. You have pollution from boats. You have pollution that comes from rivers that flow into them. You have runoff of pesticides and chemicals from agricultural lands. There's just a whole host of ways in which mankind has been negatively impacting coral reefs. But what the climate alarmists usually talk about is the rising temperatures, which they say will lead to coral bleaching. What that is, when the temperature of the water gets too hot sometimes, the corals expel the algae that live, the symbiotic algae that live within them and that provide food for them. And when they expel those algae that are providing the food, they lose the color that the algae might have had, and they also, if the algae don't come back and repopulate them, the corals die. And so this is a problem that sometimes can happen when the water gets too hot. We also find, however, that it sometimes can happen when the water gets too cool. The climate alarmists usually are talking about, well, it's going to get so warm that these corals are ultimately going to die. But the interesting thing about it is that both the coral and the symbiotic algae, they can evolve. They can evolve fairly rapidly, in fact, and they can evolve to tolerate higher temperatures, and we see evidence for that going on in the real world. Another thing that they say about corals is that the carbon dioxide rise in the atmosphere will lead to an acidification of the ocean water.
I was going to ask you about that.
Yeah, and it can cause this to occur to a certain degree, but there are a lot of experiments that have been done with corals that indicate that oftentimes the symbiotic algae that live within them, they're benefited by this increase in CO2. And so the corals do even better. And in fact, we've got a little book that we put together where we have actually looked at what's happened in the real world in terms of coral growth rates in various parts of the world over decades and centuries. And as it has warmed and as the CO2 content of the air has increased, we generally find increases in the growth of coral. So it could well be that they may do better in a warmer and a CO2-enriched world. There's a lot of real-world biological evidence that suggests that this may be the case.
Could acidification also come from volcanism? Because we're just finding out that there's many more hundreds and thousands of volcanoes in the water that we didn't even know existed?
Yeah, it could come from that,
Because
in fact, there's some places where CO2 just bubbles out of the ocean bed. And I was just reading something today, in fact, that showed that there were some, I can't remember what it was living down there by these areas where the CO2 was bubbling out, but they were thriving.
So nobody has to be afraid of carbon dioxide?
I don't think so. There's been a couple instances where there has been something bad happen. Like I think there was a lake somewhere over in Africa here, I don't know, quite a few years ago that burped, so to speak, and released just a whole lot of pure carbon dioxide that at night being heavier than air, it